Welcome back to Up in the Air. I'm Meredith Fish.
And I'm JP Nicola. Boston has been getting slammed with snow the past few weeks.
Yeah, I know. They broke their 30-day record in 17 days.
That is impressive. We haven't seen anything like that here.
No, we sure haven't. However, we will be seeing some major cold air this weekend into next week. Amanda will have more on this later in the show.
Speaking of tonight's show, we have a lot to cover this evening.
We will be covering the atmospheric river in California, wildfire smoke increasing tornado intensity, and El Nino southern oscillation.
For now, this is Update in the Air.
Often when we refer to climate change, we think of extreme weather events and rising atmospheric temperatures. But an interesting 25-year study from India is linking climate change and poverty, and not necessarily in the way you imagine. If a farmer in India loses a cow due to famine, he is more likely to sell his other livestock to keep his family fed, often at low prices. Thus, the family has lost their economic assets, which paid for their children to go to school to help the family move out of poverty. But now, without an education, escaping the poverty trap is more difficult. The World Bank is leading discussions on bringing the climate and poverty communities together to create interventions effective for both. Some of the main points they discuss involve overcoming the obstacle of climate change to help end extreme poverty, climate policies that will benefit the poor, creating strong, flexible social safety nets, and using the impacts of climate change now as an opportunity to reduce poverty. As climate change worsens, it will become harder to eliminate poverty. Therefore, governments can lead the way on combating climate change as well as working to improve the lives of the less fortunate.
Large storms like the ones that have been battering New England recently may become more severe but less frequent due to the Earth's changing climate. This Canadian-led study noted that warmer air can hold more moisture, meaning more fuel for rain, hail, and snow. In the future, global atmospheric circulation might comprise of highly energetic storms. However, fewer numbers of such events may occur as a result of the evaporation and precipitation using up more energy in the atmosphere, which could reduce the intensity of winds around the world. The study looks at how the atmosphere transports heat from the tropics towards the poles. It is part of the effort to pin down the probable effects of climate change to help everyone from farmers to city planners cope with the shifts. More powerful but less frequent storms would be more bad than good, as the intensity of rainfall can do damage to crops, and a lack of rainfall over extended periods can also do damage. Governments will meet in Paris in late 2015 to work out a global deal to limit rising emissions of greenhouse gases.
This Saturday, the Yukon Quest International Sled Dog Race begins, which follows the Yukon River between Whitehorse, Canada and Fairbanks, Alaska. Melting ice along the river in recent years is raising concerns about the impact of climate change on Alaska's state sport. The dogs actually prefer to race when it is below zero, and packing food for the race now has to be done in ways to keep food colder longer, including using bubble wrap or blocks of ice. The sleds are also carrying different equipment. In recent years, teams have carried rubber boots and raincoats for the dogs. The economic impact of losing mushing as a sport, as well as the tourism draw, is a potential impact as well. This year, Yukon officials even had to consider moving the start line due to open water and thin ice near Whitehorse. With hope for good weather this year, the sleds are still packed with extra gear.
Can smoke from fires intensify tornadoes? The answer is yes, according to University of Iowa researchers who examined the effects of smoke from spring agricultural land clearing fires in Central America that was transported across the Gulf of Mexico, where it encountered tornado conditions already in progress across the southeastern United States. This study, published in the Geophysical Research Letters Journal, specifically examined the smoke impacts on the severe weather outbreak of April 27, 2011, which produced 122 tornadoes and killed 313 people. Environmental conditions were very favorable for a large severe weather event, but research showed that the smoke lowered the cloud bases and increased wind shear, consequently increasing the likelihood for tornadoes. The researchers ran computer models which included smoke and its effects on solar radiation and clouds on the 2011 event. The goal for the future is to include atmospheric particles and their effects in operational weather prediction models.
Over the past weekend, a strong atmospheric river was present over Northern California. With little known about the weather patterns responsible for this phenomena, NASA, NOAA, and the Department of Energy deployed 4 aircraft and a research ship to gather information on the system. Atmospheric rivers are found across the globe and carry long, narrow bands of moisture from the tropics to the poles. They are responsible for about 50% of California's seasonal rainfall, as the state typically sees 6 atmospheric rivers in a typical winter. The last 3 years, there has been a reduction in the number of atmospheric rivers, contributing to the serious drought in the area. They are attempting to link the ocean and atmospheric conditions in an atmospheric river to benefit water managers in California.
Satellites planned for launch during the next several years have an expanded role that includes forecasting air quality across the globe. These geostationary satellites, which orbit Earth at about 22,000 miles above the equator, can measure the amount of smoke, dust, and other pollutants at different altitudes. The readings will be every hour and in high resolution, allowing for a better picture of the changing air quality near the Earth's surface. The data will be combined with what's collected currently by low Earth orbiting satellites to allow experts to make improved air quality forecasts. Current models capture major pollution features, but they tend to underestimate aerosol loads and surface concentrations. Adding geostationary satellite data should improve these models. Up in the Air will be back in a minute with more.
Thanks for joining us.
We now want to introduce the work of the Climate Dynamics course here at Penn State.
Students Brad Gay and James Hylack will give us an insight into the El Niño Southern Oscillation.
The El Niño Southern Oscillation, or ENSO, is a sea surface temperature anomaly in the eastern tropical Pacific that has wide-ranging global impacts.
El Niño has made headlines over the years for its impacts on weather in the United States and abroad, so meteorologists and climatologists invest a lot of time in studying and forecasting it.
As global average temperatures continue to rise, understanding the impact of warming on El Niño or La Niña is a hot topic in the scientific community. El Niño and La Niña are tied to tropical cyclone trends, so changes to ENSO could impact tropical cyclone activity across the world.
ENSO has 2 phases, El Niño and La Niña. During an El Niño, the ocean's surface is warmer than average in the tropical Pacific off the western coast of South America. Conversely, during a La Niña, waters are cooler than average.
The phenomenon is closely linked with the Southern Oscillation, which is essentially a seesaw effect of the atmospheric pressure as it builds up on one side of the ocean. This area of increased pressure naturally oscillates between the tropical Indian and the tropical Pacific Oceans.
The asymmetry created by this oscillation leads to a strengthening of the trade winds, which are the prevailing winds in the tropics. These variations in the trade winds drive El Niño and La Niña events.
These 2 phenomena together is called ENSO, or the El Niño Southern Oscillation.
Under El Niño conditions, tropical cyclone development is typically suppressed in the Atlantic Basin and enhanced in the Pacific Basin. This is because the upper atmospheric patterns associated with El Niño events increase wind shear across the Atlantic and decrease it in the Pacific.
Wind shear is the change in wind speed in direction with height. Tropical cyclones form and thrive in environments with low wind shear. If wind shear is too great, storms can be ripped apart.
Thus, tropical cyclone activity is usually reduced in the Atlantic during an El Niño. The opposite is true of La Niña years, when tropical cyclone activity is typically lower than average in the Pacific Ocean and higher in the Atlantic due to these upper atmospheric patterns.
Current studies indicate that the frequency of El Niño will not be impacted by global warming. As you can see in this figure, the frequency of El Niños and La Niñas does not change with recent warming.
However, El Niños could become stronger while La Niñas become weaker. As the temperature of the ocean rises, El Niños would be warmer, while La Niñas would be less cool. This could heighten the effects that El Niño has across the world while diminishing La Niña's effects.
In terms of tropical weather, an increase in sea surface temperatures is predicted by global climate models to decrease the frequency of tropical cyclones around the world, but increase the percentage of cyclones that become intense storms. The reasons why are not well understood, but is most likely due to changes in atmospheric circulations associated with warmer water.
This would affect millions of people living in the tropical basins, which is why it is crucial for scientists to continue to research the impacts of a warming world. For Up in the Air, I'm Brad Gay.
And I'm James Hillwack.
Thanks for tuning back in.
Amanda Reynolds is standing by at our climate wall to give us the 8 to 14 day outlook.
Take it away, Amanda.
Thanks, JP and Meredith. It sure is going to be a chilly week. I am student meteorologist Amanda Reynolds here with your climate outlook. We begin by taking a look at our current snow cover. This is updated as of February 3rd, 2015. Currently, 38% of the U.S. is covered in snow. Areas of the Northeast, such as Maine and Boston, have been getting hammered with the snow since the beginning of this year. These areas have gotten almost 36 inches, and this is just as of last week, and they've continued to get the snow to pile on, while areas here in Pennsylvania see anywhere from an inch to around 6 inches of current snow cover. Zooming out to see the rest of the United States, areas of the Great Lakes and the north central United States are quite similar to Pennsylvania, anywhere between an inch to 6 inches, while back towards the Rockies, areas like Wyoming and Montana have seen similar snow to the Northeast. Areas in Wyoming have seen almost 36 inches of snow, so it's pretty significant up in the Rockies. Looking forward to next week's pattern, we do have a dipped jet stream, which is allowing that Canadian air to come forth for the next shot of cold air into this weekend and into next week. As we put this into motion, we can see as that jet stream does dip south, it will bring that shot of Arctic air for this weekend and into early next week, which will give us pretty much the coolest air we've seen so far this season. Again, looking at the temperatures, the Northeast colder to much colder than normal, as is indicated by this dark blue color as it tapers off to the south and west. While to the extreme west, temperatures are well above normal. Areas of California and Nevada, we are expecting to be much warmer than average over the course of the next week. Talking about precipitation, areas of the Great Lakes are expected to be well below normal over the course of the next week. Here in State College, we are expecting around pretty even chances of being above or below normal. Areas to the south and towards the Central Plains are expected to be above average precipitation. Areas of New Mexico, Texas, and Arizona well above normal for the precipitation over the course of the next week and a half, while areas of the Pacific Northwest are expected to be well below normal. That's your climate outlook, and I'm Amanda Reynolds. Back to you, JP and Meredith.
Thanks, Amanda. Well, I sure am not looking forward to this bitter cold.
No, me neither. And that's all we have for this week.
As always, thanks for joining us, and thank you to all the Penn State students who contributed to the show.
Tune in next week to catch another episode. But for now, I'm JP Nicola.
And I'm Meredith Fish. See you next time, Up in the Air.